In year 11, we already learned how to solve trig equations using degrees, so we just need to transfer our skills so that we can solve them using radians. Now, first thing to do is use a diagram to work out what quadrant or quadrants your solutions are going to lie in. Think about the related angle. Then we're going to apply the correct sign for those quadrants that you've already identified, and then list all the answers that are in that given domain. Now, what do we mean by given domain? Well, if we're solving something like here in our example, we're asked to find the cos of x. Which value of x gives us -1/2? Well, the cosine curve looks like this. And it goes on and on forever in both directions. So there's an infinite number of answers to this question. But that's why they'll give you a particular domain. They'll say solve for x if x has to be between here and here, which means we're only looking for, if this is 2 pi, solutions that are in this area. All right, so step 1, we need to use a diagram to work out the quadrants. All right, now there's 2 little diagrams you might want to draw. You might want to chuck this one down, all stations to central, so that you can say, hey, if cos of something is negative, I must be needing to look in the second and the third quadrants, because I know cos is positive here and here, negative there and there. So straight away you've got 2 solutions that you're looking for. The other diagram that you might want to do, the other part of this answer, not just the negative, but the half, you might be thinking, I know that the cos of 60 degrees is 1/2. So that's my related angle, isn't it? Now, a diagram that shows that, well, if you want to draw your 60 degrees here, that's your related angle, and you've already considered that you're going to need to put your 60 degrees over here and here, which means like this and like this. Now you can use your little sketch here to do your thinking. If this is 60 degrees, just make a bit more space here to label my rays. If this is 60 degrees, we can also call that pi on 3. How do I know? Because pi is 180, so 180 divided by 3 is the same as 60, isn't it? So you might want to write that related angle down if you like. You could write down that the cos of pi on 3 is 1/2. That's a perfectly good working step to have considered. And then you might write down we need second and third quadrants. Just jotting that down really tells you what you're doing. Now, how do we put that angle into the second quadrant? Well, we know that this is pi over here at 180. So if we've got pi on 3, we need to do pi minus pi on 3. Basically, pi minus 1/3 of a pi is 2/3 of a pi. So x could be this one, which will be 2 pi on 3. Or it could be down here in the third quadrant. Now to find that one, we've got pi plus pi on 3. So if you've got 1 pi plus 1/3 of a pi, you have 4/3 of a pi, which you'll write as 4 pi on 3. And then we just double check that both of our answers lie in the domain that we've been given. Now this one is a much tougher example. You'll get these towards the end of exercise 9H. 2 sine squared x plus cos x equals 2. Now we need to get this much simpler so that it only has one trig value in it. We can't deal with sine and cos at the same time here. So you'll recall that your trig identities, which we learnt in year 11, can be very helpful. This is the one that we should know. It's actually in our reference sheet, so if you forget it, it's right there. Now, if we've got sine squared x, we could very easily rearrange this little equation to get sine squared x by itself. And how do we do that? We need to subtract cos squared x from both sides of this equation. So we'll end up with this. Now I can take this value for sine squared x and sub it in. So I've basically got 2 lots of 1 minus cos squared x plus cos x, and that equals 2. Next, expand out your brackets. And let's subtract 2 from both sides so that we have everything on the same side. Now, why am I doing that? Well, I can see that I've got some cos squareds and some cos's, so it looks to me like a quadratic equation. Now, tidying up here, I've got the 2 and now the minus 2. Those will disappear each other. Now, I'm thinking here, solving this, I've got minus 2 cos squared x plus cos x. Both of these have got a cos x in them. So if I factorise and bring my cos x out the front, I'll end up with minus 2 cos x plus 1 equals 0. Now, if something times something equals 0, one of these parts must have been 0. So I can say, therefore, cos x equals 0, or this part, minus 2 cos x plus 1 equals 0. Now I've got two parts to solve, so I've basically got two trig equations to solve. Now, thinking through cos of x equals 0, if you're nice and familiar with your cos curve, you'll know that it starts here on the 1, and by the time it's gone 90 degrees, which we're now calling pi on 2, it comes down to the 0. But it comes back to the 0 over here when it's another 180 degrees further along. So this will be at the point 3 pi on 2. So a sketch is actually one of the easiest ways to solve this. If you just type inverse cos 0 into your calculator, it will give you one of these answers, but not both. So here I can see that in our domain, and let's have our question specifying the domain, between 0 and 360 degrees, or 2 pi. For this part, I know x could be 90 degrees, or pi on 2, or, let's just put a comma, it's simpler, 3 pi on 2. Now I have to solve this part. Let's add 2 cos x to both sides. So I'll have 1 is equal to 2 cos x. Now let's halve both sides. So this cos x will be on its own and this will be a half. So cos x is equal to half. Now, I know from my exact values that cos of 60 degrees equals a half. But there's also a related angle. All stations to central. If cos of 60 is a half, then I also have an answer down here in the fourth quadrant of another angle that's equal to a half. So I need to have my 60 degrees, which I'm going to write in radians. Now 60 is a third of 180, so it's pi on 3. And I also need to put in the fourth quadrant answer, which would be 2 pi minus a third of a pi, which will give me 5/3 of a pi, or 5 pi on 3. So I've actually got 4 answers to this. Now, to make it really straightforward, when you finish a complicated question like this, you need to specify x equals, and it's kind of nice to put these answers in order, ascending. So I put this one first, pi on 3, because that's the smallest. And then I list my pi on 2, and then my 3 pi on 2, and my 5 pi on 3. And I've got all of my answers there. I put them in a box too, so it's really clear that I've finished.